Repository is a class which puts the network and local data operations into a centralized place. Repository is also a place for orchestrating the data caching. We don't need to fetch data from the network every time the user launches our app after all. If the local data is relatively up to date, we can use it instead. In this part of the series, you are going to learn how to create such a repository, and you are also going to learn how to finally set up the dependency injection so that we are prepared for the next part. Hello, welcome to Coder, and let's get started. I am currently in the weather network data source implementation which we created in the last part. So now let's close it because we are not gonna touch it in this part, but we are rather going to create a new package for all of the repositories. Actually, we are going to have only one repository in this app, but it's important enough to have its own package. So let's open up app, Java, our root package, then data, and the repository will be a separate package, sub-package under data. So right click on data, we want to create a new package, call it repository. And as we are already used to, we are first going to create the interface for our repository. So right click, we want to create a new Kotlin interface, and its name will be forecast repository. For now, the public interface for our repository will contain only one function, and that is for getting the current weather. So it's going to be a suspending function. That's because we want it to be asynchronous, and suspend keyword enables us to call this function from a coroutine, so get current weather. And it's going to have one parameter, metric, which will be of type Boolean. And as you may remember, we have two types of current weather entries. One of them is metric and the another one is imperial. Here they are under unit localized package. So if metric will be true, we will return metric current weather entry, otherwise we will return imperial current weather entry. And metric and imperial weather entries are all joined up by an interface from which they are all implementing, and that is this unit specific current weather entry. And because our function for getting current weather can return either metric or imperial, it's going to return this unit-specific current weather entry, which is their, let's call it super interface, because it's not a class, but it's an interface that they implement. So return live data, unit-specific current weather entry. Now let's again hover over the interface and wait for the light bulb, and we want to select that and implement the interface. Forecast repository IMPL is the name of the implementation. First things first, let's set up the constructor of our implementation. We are gonna have a bunch of constructor parameters which are going to be private vals. The first one will be current weather DAO, and then also private val weather network data source. And make sure that you are operating with only the data source and not its implementation, because otherwise you are going to lose the benefit of having the interface. And later on in this series, we are going to add a bunch of other properties inside this constructor. For example, for the future weather DAO and for the location DAO and also for the settings and all of that. First, let's implement our strange kind of asynchrony through live data of the weather network data source. As you may remember from the previous part, weather network data source has live data properties, which is the downloaded current weather. This live data is updated whenever a new current weather is fetched from our network API, and whenever there is a change in live data, we can observe it. So we are going to do just that in the forecast repository. In the init block, we are going to get weather network data source, and we are going to get the downloaded current weather from this weather network data source. And on it, we want to observe forever, because repositories don't have any life cycle, so we don't need to worry about this repository being destroyed, because when it's destroyed, the whole app is destroyed. So lifecycle doesn't play a role in this observer. That's why we are observing it forever. And this observe forever will provide us with new current weather. And here we want to persist the new current weather. So let's create a private function for the actual persisting of the weather. So private fun persist fetched current weather. It's going to accept the fetched weather of type current weather response. And over here, we are going to use the global scope to launch a coroutine. So global scope.launch. And I previously said that the global scope is not the best way to launch coroutines. However, in a repository, it's different than in the fragment, because a fragment has a lifecycle. So there you have to account for that lifecycle, and whenever the fragment is destroyed and you are launching something through global scope, and the coroutine code finishes later when the fragment is already destroyed, you are going to get an exception, which makes sense. However, in the repository, which doesn't have a lifecycle, we can use global scope and not only some kind of a local scope, for the same reason that we can use observe forever and not just observe with a lifecycle, because lifecycles don't matter inside a repository. And that's one of the beauties of using MVVM and not sticking everything to an activity or a fragment. You don't need to have the lifecycle in your mind at all times. Also, this launch will not be just some kind of an ordinary launch. We also want to specify a dispatcher, and it will be an I/O dispatcher. And by the way, if you want to learn more about coroutines in Kotlin in depth, you can check out my tutorial by clicking on the card in the corner. Coroutines are basically lightweight threads, and this dispatcher's I/O will ensure that we can spin up a massive amount of little threads at once and also then destroy them, and we aren't going to get any performance penalties. Alright, then what do we want to do in this coroutine? Well, we want to get current weather DAO, and then we want to upsert, which is update or insert, the fetched weather. And from the fetched weather, we want to get the current weather entry. So that's it for now for this persist fetched current weather function. And now we can call this function from the init block, and we want to pass in the new current weather. Now we can go to the get current weather function, which is part of the public interface. And we also want to make this function into a coroutine. So we can call with context and also dispatcher's IO. And basically the difference between launch and with context is that with context returns a value. Launch doesn't return a value, but it instead returns a job. And currently we aren't doing anything with the job. We aren't even putting it inside a variable, but it doesn't matter. With context returns something. So actually we also want to have a return here. And from this with context, we want to return, so return at with context. If we want to return the metric, we're gonna call current weather DAO dot get weather metric. Otherwise, so else, if we want to get the imperial weather, we are going to call current weather DAO dot imperial, so get weather imperial. And we have a problem with generics. If we take a look at this error, it writes that we are returning out unit-specific current weather entry, but the interface has written only unit-specific current weather entry without the out generics modifier, so to say. So we need to put out over here, and also to the definition of the interface, so also here. And now the error is gone. What this does is that it basically tells the generics that we can also return classes which only implement unit-specific current weather entry and not only directly unit-specific current weather entry. However, now we have a bit of a problem, because in the init block, whenever there is a new value for the downloaded current weather, we are persisting it to our local database right over here. And from the get current weather, we are only returning the stuff that is already in the local database. What's missing here is the network call, which will actually initiate the first caching of the data inside the database. Because currently the forecast repository doesn't handle the network fetching at all. For that, we need to create another private function, init weather data, and this function will be called from the get current weather context, so init weather data. And this new function actually also has to be suspending, so private suspend fun. And over here we want to check if we need to fetch the current weather from the network. This means we will create another little function, isFetchCurrentNeeded, so private fun without suspending. And this will have one parameter, last fetch time, and it's going to be of type zoned datetime, right over here, but it's going to be from orc310 BP and not Java time, because this orc310 BP is backwards compatible with older versions of Android. And this function will obviously return a boolean, because it's a boolean helper function. And over here we want to have one immutable variable, val 30 minutes ago. And what was 30 minutes ago? Well, it was whatever is now, so zoned datetime dot now. This is the current time. And we want to subtract 30 minutes, because that's 30 minutes ago, right? So minus minutes, and we want to subtract 30. And then from this function we want to return if last fetch time is before the 30 minutes ago. Pretty self-explanatory. And while we are at it, let's also create the function for actually fetching the current weather. So another private suspend fun, fetch current weather. And over here we simply want to call weather network data source, fetch current weather. And we want to pass in, for example, Los Angeles for now, for the location. Later on we are going to get the location from the settings or the current location of the device. For now, we don't have anything with the location implemented, so I am just going to pass a hard-coded value over here. And with the language code, we can actually pass in something meaningful and not hard-coded. We can get the current device language from locale, get default, and then we want to get simply the language, which is the code for the language. And notice that we aren't returning anything from the fetch current weather. That's because in the weather network data source, this is going to fetch the weather, and then it's going to update the live data downloaded current weather. And we are observing this live data from the init block. So as soon as this downloaded current weather is updated, so this means it's fetched from the API, we are immediately going to persist it to our local database. Pretty cool, isn't it? So now let's finally finish up our init weather data function. We want to check if isFetchCurrentNeeded. Later on, we are going to get the time of our last fetch from the location, which will be stored in the database. But as you know, now we don't have anything with the location implemented, so I am going to pass here a dummy value. And this dummy value will be that we will always need to fetch the current weather, because the time that we are going to pass here will be 1 hour ago, so zoned datetime, not of instant, but now. And then we want to say minus hours 1. And because in the isFetchCurrentNeeded we are returning true whenever the last fetch was 30 minutes ago or more, this expression will be always true. And if it's true, so always, for now we want to fetch current weather. Alright, now let's quickly implement the dependency injection. For that, we are going to subclass the application class. So under the root package, we are going to create a new Kotlin class, forecast application, and it's going to be a subclass of application. And because we are using Kodein for the dependency injection, it's also going to be Kodein aware. And when something is Kodein aware, it needs to have an overridden val Kodein, which will be equal to Kodein.lazy. Oh, and also we need to call the constructor of application class here. I immediately want to say that if you want to learn about Kodein in depth, you can check out my separate tutorial by clicking on the card in the corner. Alright, so here we first want to import Android X module. So import Android X module, and the app is this add forecast application. What this does is that it will provide us with instances of context, various services, and anything that is related to Android, so that we don't need to code that ourselves. It's already coded by the Kodein's coders, right? But we also want to have our bindings. The first one will be for our forecast database. So bind, and let's import this from Kodein DI generic bind. And what do we want to bind? We want to bind the forecast database. Forecast database doesn't have any kind of an interface. We're going to bind the forecast database directly. So we can use bind from. And forecast database, it doesn't make sense to have two instances of the database at the same time. So we want this to be a singleton. And this binding will return forecast database. We are going to call the invoke operator on it, so we don't actually need to call invoke like this, but we can just have two parentheses like if we were normally instantiating a class, but we aren't. But that's the beauty of invoke operator. And what does this invoke function need? It needs a context. So how are we going to pass in a context to this database from this binding? Well, we are going to use the already pre-programmed Android X module. So we don't need to do anything special in here. We can just pass in instance. And let's also import that. And through the power of type inference and also through the power of Kodein, this instance will be returned from the Android X module, and the instance's type in this case will be context, which is the application context. Alright, then similarly we want to bind our DAO. So we are going to paste the line in here, but we are gonna delete forecast database, and instead we want to get the DAO from this forecast database. We need to get the instance of the forecast database, so we somehow need to get whatever is returned from this binding, and we want to get that instance to this singleton down here. We can do it by calling instance, then specifying that we need an instance of the forecast database. So Kodein is going to call the line above to get the instance, and from this instance we want to get current weather DAO. So now we have bound forecast database and also current weather DAO. But if we take a look at the Apixu Weather API service, we can see that we are also passing connectivity interceptor around, so we also need to bind this connectivity interceptor. What's different about this connectivity interceptor in comparison with these two bindings which we created previously is that connectivity interceptor has an interface, but it also has an underlying implementation. So we are going to use bind as usual, but we aren't going to bind from. We're going to bind. Actually, we need to specify the type over here, which is the connectivity interceptor interface. And we are going to bind this interface with a singleton. And this singleton will return connectivity interceptor implementation. And this implementation also needs an instance of context. So again, instance. And the context will be pulled from the Android X module. Then we also want to bind a Apixu Weather API service, so copy the line binding the database, paste it down here, because a Apixu Weather API service is simply an interface. It doesn't have any interface and implementation separation kind of. So we are going to bind from singleton, and we want to bind a Apixu Weather API service here. And a Apixu Weather API service needs an instance of the connectivity interceptor. So we are just going to call instance here, and the Kodein will get this instance from the line above. And now really similarly, we need to also bind weather network data source. So just change connectivity interceptor to be weather network data source, and we are going to return weather network data source implementation, and also pass in the instance, which in this case will be the Apixu Weather API service. And lastly, for now, we need to make sure that we also bind the forecast repository. So bind forecast repository. We want to return the forecast repository implementation. And the repository needs two instances, not just one, because one of them is for the current weather DAO, and another one is for weather network data source. So instance and instance, and we are good to go here. Even though we aren't going to test this app in this tutorial, the way that we have this set up now would not work. even though we are subclassing application with our forecast application, this forecast application is, let's say, not yet hooked into our real app. For that, we need to go to the Android manifest, over in manifest and then Android manifest. And we need to set the name of our application, so Android name, to be forecast application. And let's also get rid of the squiggly line. So let's suppress Google App Indexing warning. And now whenever we launch the app, it's going to launch through the forecast application class, which we have just created. Alright, then that's it for this tutorial. If you don't want to miss the next part of this tutorial series, be sure to subscribe to this channel and also hit the bell button so that you will be notified about each and every video that I upload. If this video helped you with creating the repository and also helped you to understand the dependency injection a bit, give this video a like and also share it. Remember that you can get the code from this tutorial by clicking on the link in the video description, which is gonna take you to resocoder.com. Leave a comment if you have anything to say, follow me on Instagram, Facebook and Twitter, and see you in the next video.